We're going to go ahead and take a look at number 21 from section 1.2, which deals with applications of linear equations. If you don't have your textbook, I would suggest that you go ahead and grab it. I won't be able to write down the full question, so definitely make sure that you have the problem out in front of you and also have your pen and paper ready to jot down some notes as you read through. So number 21 is an investment problem, and an executive invests $22,000, some at 7%, some at 6% annual interest. If he receives an annual return of $1,420, how much is invested at each rate? So we know that this executive is starting with this lump sum of $22,000, and what this executive is going to decide to do is invest it in two different investments. So the type of investment that we're going to look at might be a good way to organize our information. One of them is at 6% and the other is at 7%. So we know that the rate, we'll go ahead and we'll convert this straight off the bat. We're going to remember that we can't work with percentages directly. We want to convert it to a decimal. So if we convert 6% to a decimal, it'll be 0.06 or 6 hundredths, and 7% becomes 7 hundredths. The next thing that we can talk about would be the amount of money that is invested into each type of investment. So we know that the executive will be entering a certain amount of money into both investments, but it really doesn't say how much for each investment. So if you are starting to work with the 6% investment, you would say, well, I don't know how much this executive has put in here, so for now I'm going to put X in there to hold its place. That being said, then, you can kind of piggyback off of this idea. If you put X amount of dollars into the 6% investment, then that means that you would have put in the remaining amount, which is going to be that $22,000 minus the X dollars that you used in the 6% investment. Okay, this is going to generate your interest then. What we can do is, I'm going to go ahead and note this in red, we can do rate times the amount of money will equal the interest. So what that will look like will be 0.06 times X, and then 7 hundredths times 22,000 minus X. So that entire quantity that's happening there. Okay. So let's move forward. We know that at the end, the goal that this financial executive wants is to bring in an annual return of $1,420. So this is going to be the amount of interest that this executive has raked in for the company. So that being said, then we can say interest from 6% investment plus interest from 7% invest is equal to that goal amount of 1,420. So now we can kind of go ahead and add in a little bit more of our math symbols here. So that would be 0.06x plus 0.07 times the quantity 22,000 minus x is equal to 1420. Okay. From here, it's just going to become your basic solution here. So we're going to go ahead and hit this with our distributive property. So this is going to give us 0.06x plus 1,540 minus 7 hundredths x is equal to 1,420. Go ahead and subtract 1,540 from both sides. And we can also combine these two terms because they are like terms. So this is going to give you negative 1/100th times x is equal to negative 120 And then we want to undo that multiplication, so we will divide both sides by that negative 100th, and we will find that x is equal to $12,000. Okay, double check and read through the question again. They want to know how much is put into each account. So if we know that $12,000 is in the 6% investment, then we can say that the $22,000 minus the $12,000 that we used in the other investment, that means that we are going to put in a grand total of $10,000 in the 7% investment. Okay, so there are your two solutions, and if you have any further questions with this particular application problem, please come and see me.